Dear students, in this class we have to discuss about merits of Bohr theory. In the last session we have discussed about the postulates of Bohr theory, and after that we are now coming to merits of Bohr theory. Before coming to the merits of Bohr theory, we should remember the demerits of Rutherford. To overcome that drawbacks of Rutherford model, Bohr introduced certain modifications, and now this model is capable to explain the difficulties faced by Rutherford. We have to see it one by one. First one, explain the stability of atom. First demerit of Rutherford was his failure to explain the stability of atom. According to his model, when a charged body revolves around the nucleus, definitely there will be a decrease in the radius of the orbit, and finally that electron will fall into the nucleus as a consequence of the electromagnetic wave theory. But here, to overcome that difficulty, in the first statement itself, or first postulate itself, Bohr declared that electron moving through an orbit of fixed radius and definite energy, there will be no chance of change in the radius of orbit. So there will be no possibility of falling electrons to the nucleus, which leads to the collapse of the atom. So such situation is effectively prevented by the Bohr model. That's why we are telling that he successfully explained the stability of atom. Second demerit of Rutherford was his inability to explain the energy of electrons, which actually done by Bohr here. He calculated energy of electron in any particular orbit. At the same time, you should remember that this model is applicable only for hydrogen or hydrogen-like atoms. That means atoms or ions with a single electron. For calculating energy of electron in such a system where no chances of inter-electronic repulsion, the equation can be written as energy of electron in nth orbit or nth shell equal to -1312 into z square by n square if unit is kilojoule per mole, which is the normal unit of energy. In kilocalories per mole, we can write it as -313.6 into z square by n square. -13.6 is the constant in electron volt per atom. Whatever may be the unit of energy used, the variables are same, z and n. Z means atomic number and n means the shell number. Suppose an electron is moving through the fifth shell of hydrogen, then we have to put 5 square in the denominator. Or if we have to calculate the energy of helium plus. Helium plus is hydrogen-like species. Why? Because it contains only one electron as hydrogen. Atomic number of helium is 2, but electron is 1 in He plus. So, in the case of helium, we have to put Z square as 2 square. Atomic number of helium is 2 square by n square. So, variables are same or common in any equation, but by changing the unit of energy, constant may be changed. And one more unit is there, that is the joule per atom. In this unit, energy equal to minus 2.178 into 10 raised to minus 18. This was his second merit. That means explaining the energy of electron in hydrogen or hydrogen-like species. And third one, he successfully calculated the energy difference. Energy difference between two energy levels. Suppose we have a nucleus, first shell and second shell, 2, 1. We have to calculate the energy difference between the two. Energy of the first shell is called E1 and E2 for second shell. Then change in energy delta E equal to E2 minus E1. Now we have to remember that E2 equal to minus 1312 into Z square by N2 square minus, for E1 we have to write minus 1312 into Z square by N1 square. So commonly we are writing it as 1312. Minus of minus become plus. That is why we are writing it as plus 1312 into 1 by N1 square, this term, minus 1 by N2 square, this term. And commonly we have Z square. That can be taken out. It is not 2 square, it is Z square. N1 lower energy level and N2 higher energy level. If you have to calculate the energy difference between 5 and 2, then here you have to write 2 square, here you have to write 5 square. Depending on the question, you have the choice of N1 and N2. One thing you have to note down here is that energy of single electron is always negative. Energy of single electron is always negative, but energy difference is always positive. Next merit or fourth merit is explanation of hydrogen spectra. Explanation of hydrogen spectra. Suppose a hydrogen gas is taken in a discharge tube at very low pressure. When high electric potential is applied at low pressure, temperature of the gaseous system gradually increases and finally it will reach a condition where bond between hydrogen molecules are broken. When the bonds between hydrogen atoms in every molecule is cleaved, they are all become hydrogen atoms like this. Hydrogen atoms like this. You can see many hydrogen atoms which are actually formed from hydrogen molecule by the cleavage of the bond between them by applying high potential at low pressure. Each of the atom in discharge tube now contain one electron each. these electrons can accept energy from the applied electric potential or from the heat generated. This energy leads to the excitation of electrons. Excitation of electrons. But you know that the excited state of electron is never stable. So these electrons undergo de-excitation to lower level, during which they can release the energy. So nucleus surrounded by many energy levels. Now electron is present here. This electron get excited to higher level. Since excited state is unstable, definitely this electron will de-excite by emitting the radiation absorbed during their excitation. This energy actually, when analyzed using a spectroscope, we can see the hydrogen spectra. The instrument used for producing the spectra of an element is called spectroscope. Spectra of hydrogen is called hydrogen spectra. That is the characteristics of hydrogen, and it is found to be blue in color. What is the next merit? That is really important. Explain why so many lines are present in hydrogen spectra. Explained why so many lines are present in hydrogen spectra. Actually, hydrogen atom contain only one electron. When this electron get excited and then de-excited, definitely you have the scope to expect only one line, because only one electron is present in hydrogen. But when spectroscopically hydrogen spectra when analyzed, we can see tremendous amount of or unlimited number of lines are present in the hydrogen spectra in UV visible and IR regions. Why such lines are present? That explanation is clearly given by Bhor as given below. It is the energy levels of hydrogen atom. This is first level, then second level, first, second, third, fourth, fifth, sixth, seventh level. One thing you have to keep in mind is that as we move from lower level to higher level, energy difference between the levels decreases. Level gap is maximum between 1 and 2. There is a slight decrease between 2 and 3, and slowly the change in energy decreases, and after 7 or 8 you will not get clear lines. Instead, very close lines or bands of energy levels are formed. So we are usually writing up to 7 or 8. Beyond that, there is energy difference is negligible, and band of energy levels are possible. Suppose one electron is present in first level. By accepting the energy, they get excited to 7th level. That electron can de-excite to the first level directly, or it can de-excite to second level, then to first level, or to third level, then to second level, then to first level. That is this one. Or otherwise, from this second level, they can directly go to the first level. That is another possibility. Otherwise, he can come to fourth level, fourth to third level, then third to second level. That is already represented by this line, then second to first line. Or directly can be there, this line. This kind of large number of possibilities are there. 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1, and 7 to 1. 3 to 2, 3 to 2, 4 to 2, 5 to 2, 6 to 2, 7 to 2, then 4 to 3, 5 to 3, 6 to 3, 7 to 3, then 4, 7 to 4, 5 to 4, 6 to 4. This kind of many lines. One more line is there. This is one. If the electron falls to first level, whatever may be the starting level, second, third, fourth, fifth, sixth, or seven, we are not at all worried about the origin from where it is coming. But if it falls to the first level, that line is called Lehman series. That series is called Lehman series. If the electron jump to second level, that is called Balmer series, Balmer. Then third level, ending lines are called Paschen series. Then fourth level, ending lines are called bracket. Then next one is fund. If n equal to 1, n1 equal to n equal to 1 Lehman, n equal to 2 Balmer, n equal to 3, n equal to 4, n equal to 5. So sometimes you can expect Humphrey line also when n equal to 6 here. So this kind of large number of lines are possible in hydrogen spectra. How to explain it? When high electric potential is applied through hydrogen gas at low pressure, at first, because of the high temperature, bond get cleaved and all of them become atoms. Each of the hydrogen atom contain one electron each, and all these electrons get excited to higher energy levels, depending on the amount of energy absorbed. It can goes to second if it less amount of energy is available. It can go to 7 level if it is if available higher amount of energy. Depending on the amount of energy available, they can excite to various energy levels, second, third, fourth, fifth, sixth, seventh, etc. Whatever may be the higher energy level, all the excited levels are unstable, so they can de-excite in a single step. That means directly to first level or in many steps. Then first to 2, then to 1, or 3, 3 to 2, then 2 to 1. This kind of possibilities are there. All these possibilities producing large number of lines in different series. Okay. This concept should be there in your mind. It may be asked for your exam. Next one, Ritz combination principle. It is actually related to spectrum of hydrogen. Wave number of spectral line. Wave number. It is the number of waves in unit length. Wave number equal to RH into 1 by n1 square minus 1 by n2 square. Suppose an electron is de-excited from n2 to n1, then the wave number is given by RH, Rydberg constant, 109,677 centimeter inverse is the value of RH. 1 by n1. n1 means lower energy level than n2. As we have seen in the previous slide, we have Lehmann, Balmer, Paschen, bracket and Fund series. If the line terminates at n1, it is Lehmann. n equal to 1, Lehmann. If it ends at second level, it is Balmer. Third, fourth, fifth. So, it is very clear that the n1 for line is fixed from the name itself, Lehmann. n1 equal to 1, there is no other choice. Paschen means n1 equal to 3, there is no other option for n1. Fund means n1 should be 5, there is no chance of other options, but n2 may be changed. For Lehmann, if n1 equal to 1, n2 can be 2, 3, 4, 5, etc. Balmer, n1 2, then 3, 4, 5, 6, etc. Paschen, 4, 5, 6, etc. 5, 6, 7, etc. 6, 7, 8, etc. These are the n2. Lowest level is n1. Next higher level onwards, we can write n2. If you have to find out the wave number of first line in Lehmann series, first line is 2 to 1. First line is 2 to 1. Second line is 3 to 1. Third line is 4 to 1. Fourth line is 5 to 1. 5 to 1. What is n1 and n2 for the third line of Paschen series? Paschen means this series. Here 4 to 3 first line, 5 to 3 second line, 6 to 3 is the third line. This is the way how we can determine n2. You have to carefully read the question before coming to the problem to fix the n2. In question, you may be asked to find shortest wavelength or longest wavelength. Since nu bar equal to 1 by lambda, nu bar is 1 by lambda. Shortest lambda means highest nu bar. Longest lambda means shortest nu bar. Actually, this equation, Ritz combination principle, is originated from this diagram, and in this diagram, shortest wavelength energy is equal to hc by lambda. They are inversely proportional. Shortest lambda means highest energy. Longest lambda means lowest energy. In Lehmann series, longest wavelength line in Lehmann series, line of longest wavelength, that is the question. Then you should remember that longest wavelength means shortest energy. Then 7, 8, 9, etc. up to infinity is possible. Two chances we are taking. Infinity to 1, that is Lehmann, and 2 to 1. These are two extremes of Lehmann line. One is 2 to 1, then alpha to 1. In which transition maximum energy change is possible? This is higher energy change or maximum energy change. This is the minimum energy change. This is maximum. Energy change is maximum means E is high. Then lambda should be low. Shortest wavelength means infinity to 1. Longest wavelength means longest wavelength, lambda longest is possible if energy is low, then 2 to 1. This kind of questions may be asked for Bhor, which is the shortest wavelength. Shortest wavelength means highest energy, that means infinity to 2. Longest wavelength if asked you, then it is 3 to 2. Here one more thing you have to explain in Bohr theory is that he successfully explained the radius of atom. Rn equal to R0 into n square by z. N square by z. N is the shell number and z is the atomic number. If you have to find the radius of fifth shell in hydrogen atom, then you have to write R0 into 5 square by z. Not 2, it is z. Z is atomic number. This R0 is called Bohr radius, having the value 52.9 picometer, otherwise 0.529 angstrom. There also you have n square by z. This is the equation for calculating radius of the atom. Now you have to see what are the limitations of Bohr theory. What are the limitations? We have discussed lot of merits for this theory, but more than 5 demerits are there for this theory. First one, fine splitting of hydrogen spectra could not be explained. Fine splitting of hydrogen spectra could not be explained. That means when we examine the hydrogen spectra under normal spectroscope, we can see Lehman, Balmer, Paschen, Brackett, Fun, 5 series of lines. But if we use a spectroscope of high resolving power, these lines will further split like this. This is the fine splitting of hydrogen lines. It could not be explained by Bohr theory. When we apply electric field perpendicular to the spectra, they undergo splitting. Such splitting is called Stark effect. What is Stark effect? It is the splitting of spectral lines under the influence of electric field. If we are able to apply magnetic field, then there also we can see splitting of spectral lines. That is called Siemens effect. He failed to explain both these effects, Stark and Siemens. Why there is a splitting of spectral lines when we are applying electric or magnetic field perpendicular to the spectral lines. Third one, this theory can be applied only for hydrogen-like species. That means one electron species, hydrogen, helium plus, lithium 2 plus, etc. But in multi-electron system, MULTI, multi-electron system, there will be interelectronic repulsion. If more than one electron is present in shell, they will repel each other. That will definitely change the energy and stability of the atom. That condition could not be explained by Bohr. Next one, he could not explain bonding. Why atoms participate in bonding? What kind of bonds are there in chemistry? For what purpose atoms are engaged in bonding? These kinds of questions could not be answered by Bohr in that time. He could not explain dual nature of matter. Dual nature of matter proposed by de Broglie, that we will see in next slide, next class. And uncertainty principle. He also failed to explain uncertainty principle of Heisenberg. These are the basic demerits of Bohr. By this, we completed the classical concept of atom model.